Consider the linear transformation w equal to 1 plus iota into z plus 2 minus iota. We need to determine the region in the w plane into which the rectangular region bounded by these lines in the z plane is mapped under this transformation. So let's check what kind of region is transformed into the w plane. So here these lines are given to us in the z plane. And the transformation w equal to this right hand side is given to us, and we know that this w can be written as u plus iota v equal to 1 plus iota, and z can be written as x plus iota y plus 2 minus iota. We need to separate the real and imaginary parts. So from here I get again u plus iota v, and in the right hand side, so this is equal to x plus iota y plus x iota plus iota square y becomes minus y, because iota square is negative 1, plus 2 minus iota, right? And now comparing the real and imaginary parts, the real part will be from here x and then minus y plus 2. So this is x minus y plus 2, and the imaginary part will be equal to y plus x minus 1, or x plus y minus 1. Is it okay? Fine. Alright. Then what is the first line given to us? X equal to 0. So x equal to 0 maps into, just put here x equal to 0, we get, if this is 0 we get 2 minus y, u to be equal to 2 minus y, and v will be equal to, if I put x equal to 0 I get y minus 1. So that is, if I add these two I will be getting u plus v to be equal to, on adding this y is cancelled out with this minus y, and we get here 1. Very fine. Okay. Now for the second line, y equal to 0, the value of u will be, y is 0, u becomes x plus 2. And here if y is 0, v become x minus 1. So here I am having x, here also I am having x. So let's subtract these two equations so that I can cancel x. So u minus v will be equal to, this x will be cancelled out with this, and 2 minus 1, that is 3. So when putting x equal to 1 over here, I get u equal to 3 minus y. Very carefully. And then when putting x equal to 1 over here, we get v equal to y. Because it is having the opposite signs, let's add these two equations so that we can cancel v. So u plus v is equal to 3. Then the line y equal to 2, the last one. Putting y equal to 2 over here, we get u equal to x. And putting y equal to 2 over here, we get v equal to x plus 1. Now x is having the same sign, so let's subtract these two. So u minus v is equal to minus 1. Or we can also write this as v minus u to be equal to 1. Right? Okay. Let's mark the regions now. Here in the z plane, what are the lines given to us? Okay. It is x equal to 0, this line. Y equal to 0, of course. And then the line is x equal to 1 and y equal to 2. So x equal to 1 and y equal to 2. So the region formed is a rectangular. It is a rectangular region in the z plane. Let's check what this region be transformed into the w plane. For that we need to construct the lines. For the w plane, what is the first line? It is u plus v equal to 1. So u plus v equal to 1. When putting u equal to 0, I get v equal to 1. And when putting v equal to 0, I get u equal to 1. So 0, 1 and 1, 0. Okay, 0, 1, that is this point. And 1, 0, that is this point. So u plus v equal to 1 is this line. So this is u plus v equal to 1. Then another line is u minus v equal to 3. U minus v equal to 3. If I put u equal to 0, I get v equal to negative 3. When putting v equal to 0, I get u to be equal to 3. Right? Okay. 0 minus 3. That is this point. And then 3, 0. That is this point. So this line is like this. U minus v equal to 3. Right? Okay. Next one is u plus v equal to 3. Similarly, this can be formed as when putting u equal to 0, we get 3. And when putting v equal to 0, we get 3 here. So 0, 3. Again the same point. And 3, 0. That is this point. So the line is this one. So the line is u plus v equal to 3. And then v minus u equal to 1. When u is 0, we get v to be 1. When v is 0, we get u to be minus 1. 0, 1, that is this point. And minus 1, 0. This is negative 1, okay. This point. So extending this line, we are getting this line to be v minus u equal to 1. So this is the required region in the W plane. So what we have concluded? We have concluded that the rectangular region in the Z plane is mapped into the rectangular region in the W plane. Very fine. Okay. Let's check the magnification factor. Magnification factor can be found by taking the mod of the coefficient of Z. So the magnification factor will be mod of 1 plus iota, that is equal to square root 2. So the rectangle in Z plane is magnified by the factor square root 2. Let's check the angle rotation. So that will be argument of 1 plus iota, the same. So that will be equal to the tan inverse, the imaginary part, that is 1 divided by the real part. So tan inverse 1 will be equal to pi by 4. So it is rotated through the angle pi by 4, that is 45 degree. And now let's check the translation part, in which direction it is translated and through what distance is checked by this vector, right? So the region is translated in the direction of the vector 2 minus iota. The vector 2 minus iota through the distance. What is the distance? Take the mod of 2 minus iota. Through the distance, mod of 2 minus iota, that will be equal to square of the real part plus square of the imaginary part under the root. So that is equal to square root 5. So the direction of the vector is 2 minus iota, and through the distance square root 5. This is the distance. Right? That means here if I take the points A, B, C. So these A, B, C points are transformed into the points. This is A dash, B dash, C dash, and this is O dash. The origin in the Z plane is transformed into the point 2 minus iota, right? If I check this vector in the coordinate form, this is the real part is 2, imaginary part is minus 1. So 0 is transformed into the point 2 minus 1. That is this point. This is 2, this is negative 1. So this point is 2 minus 1. So let's write this. The points A, B, C are transformed into the points A dash, B dash, C dash, and the origin in the Z plane is transformed into the point 2 minus iota, that is 2 minus 1 in the W plane. Alright, thank you.